statistical modules, which will definitely go a long way in driving your projects towards success. So far we are done with the define phase, we are done with the measure phase, we are done with the analyze phase also. In define phase, our goal is to get our project charter approved, because the approval of the top management is the key. The support from the top management is the key. The support and blessings from the project sponsor is going to make all the difference. So make sure you get his support by ensuring that your project perfectly aligns with the organization's priorities, nothing but the strategies, right? And then you have the benefits and the efforts defined very clearly in your project charter. So what happens? Your project gets approved. And now you move on to the measure phase. And here in the measure phase, you wanted to first of all verify the problem. You're verifying the problem. How do you verify? You cross verify it with the data, because in the define phase there are certain assumptions, right? People's opinions are taken into account, the past records are taken into account, their voice are taken into account, but ultimately whatever you are writing in the project charter, whatever you are assuming in the project charter should be based on the facts. So in order to understand the fact, you collected data, and then based on the data, you are now able to verify the existence of the problem, whether a problem really exists, or is it a kind of type 1 or type 2 error. Type 1 error is, a problem might exist and then you might think that there is no problem. Sometimes the problem may not exist and you will still think that, there is a problem. So these kind of, or it can be an in-between also, right? The type 1 and type 2 error. So we have to be very careful with knowing the fact about the problem, and for that you need to have a very good measurement system. A measurement system is considered really good and acceptable only when the measurement error is limited to less than 10%. Less than 10%. And that's the reason why you have learned the gauge R&R, you have learned the tools like bias, linearity, and stability, and you should be able to handle all of them very effectively, so that you can validate the measurement system and you can be sure about the amount of error a measurement system can bring when you actually use it for data collection. And the goal is it should be less than 10%. If it is more than 10% or in the range of 10 to 30%, then it is conditionally acceptable. But in any case, more than 30%, the measurement system is unacceptable. Whether you are using a steel rule, you are measuring an inch, you are using an inch tape, or you are using a vernier caliper, or you are using a dial gauge, or you are using, coordinate measuring machine, everything will bring the error. You first of all, you must recognize that, and you should ensure that the error with respect to the working range or with respect to the customer provided tolerance is less than 10%. This is what we call it precision tolerance ratio. And we also call it as gauge R&R, right? And so having understood about the measurement system, having sure about the measurement system's capability, you proceed with the data collection so that you can now come to know about the intensity of the problem. We call it the baseline performance. The problem is actually the difference between the baseline and the targeted result. Your targeted results you have declared clearly in the project charter. And with the help of the data, now you got to know the baseline. Baseline can be in terms of yield. Baseline can be in terms of DPMO. Baseline can be in terms of PPM. Baseline can be in terms of CPCPK, PPPPK, sigma level, or you can also calculate the baseline in terms of rejection rate. Ultimately, everything, land up in one place only. So the baseline is known and target is fixed. And so the gap is clearly understood. This is the main deliverable of the measure phase. The gap in the performance is clearly understood by the project team, right? So the baseline performance is the main deliverable. Now you move on to the analyze phase. Now the goal is to identify the root cause for the gap in performance. Why there is a root cause? Why there is a variation, why there is a lot of wasteful activity, why there is a lot of risk. So you have different tracks to attack variation, to attack waste, and to attack risk. For variation, we have the Six Sigma methodology, we have the tools. And for waste, you might think about lean tools. You will be having a session today exclusively on lean, so that you will be able to attack even the inefficiency. Suppose if there is a problem with respect to the risk level, then FMEA, tools like FMEA can be used to bring down the risk level. So ultimately, we want to figure out the root cause. But before before landing to the root cause, you should know the potential root cause. Before landing on the potential root cause, you should know the possible root cause. So that is the reason why we have been discussing with you several tools: brainstorming, Y-way analysis, fishbone analysis, impact control matrix, or some form of prioritization matrix, multi-voting. Do anything that works best in your environment. So try to move from possible causes to potential causes, and then you should be able to figure out the critical causes. If there are multiple critical causes, which is having the more impact? And for that, I'll be teaching you a session today on regression analysis, which will clearly tell you what is the amount of impact you can expect from a particular root cause. It can be X2, it can be X4, or it can be X5, whatever it is, right? So whichever is making a huge impact, that is the potential threat. That is the main root cause. Then there could be other root causes. So what I'm trying to say here is the percentage contribution by the root causes needs to be understood. Accordingly, you need to come out with the solution generation idea, and the solution generation, solution implementation, and controlling the improved result. All these things will happen in improve and control phase. But what we are going to do now is we are going to park our learning for some time. Right? We have been talking about several topics, several tools, several techniques, so long for the last 3 years. We are going to give ourselves a small rest, and then we are going to spend some time, quality time, in learning a case study. Right? How we implement, how we deploy the Lean Six Sigma or Six Sigma projects in a real-time environment. So we are going to listen to a case study so that we understand the implementation challenges when we are actually floating a project typically in an industrial setup. What kind of challenges we might come across, what kind of tools and techniques we use at various stages. Thereby, we smoothly drive the improvement and then produce the result as per the timelines and the target, right? So for that is going to be our first session today, a case study, and which will be offered by our co-trainer, Mr. Vinod Shankar. I once again, as a formality, I remind about how you need to participate. Make sure you participate well. Always, whenever there is no screen sharing, you are expected to be on video. When there is a PowerPoint slide, when the trainer is focusing on covering the topic, and that's the time you can relax by turning off your video. But all other time, you are expected to be on video, and you are expected to have a lot of interaction, right? And also, please do not mind stopping the trainer at any point of time. You are with the platform where your interest is of high respect, right? If you wanted to learn something, you can go to the extent of stopping the trainer and then raising your question. So this is how we expect you to participate. So wish you all the very best for a great learning on day number 4. And time is for the case study. Over to Mr. Vinod Shankar.
Okay, good morning all.
Good morning.
Good morning, sir. Good morning.
Morning, sir. Morning all.
All
So,
you.
yeah, great. So let us have a great morning, all right?
Yes.
With a case study. This case study is more generic in nature. I mean, it is not specific to any manufacturing kind of thing. It is little bit generic in nature, so that everybody can be, understanding what exactly we are discussing in that, right? So I'm going to show you one case study, and yeah, Sandeep, little kid. Yeah. Okay, so shall I start?
Yes, sir.
Yes.
Okay. So we will start with the case study, which is this case study is related to HR in the industry. What is the issue is that there are some operator attrition is happening in one of the plants, right? You know all attrition. What is the meaning of attrition?
Leaving
Yeah,
the
people
association of
leaving.
the
They don't stay.
organization.
They don't stay. They go away, right? And